This is a video to help us understand or kind of remember a few things about linear equations. Linear equations are something we've worked with for quite a while in pre-calc. So we're just kind of doing a quick reminder here. Remember, if we have an equation of the form, such as we do on the right here, y equals negative 2/3 x plus 4, that form is our y equals mx plus b form. Technical name for that is slope-intercept form. Again, we like that form because it's a really quick and easy thing to graph. Again, our slope is going to be a negative 2/3. Our y-intercept, or what we often call b, is 4. And so we can start by traveling up the y-axis, 1, 2, 3, 4, and plotting a point, and then using that negative 2/3 as our slope. Now remember, our slope, which is the formula over here at the left, m equals y2 minus y1 over x2 minus x1, basically comes out to negative 2/3. Our slope is basically telling us the change in y values, the change in the vertical coordinate, right? Oops, and sorry there. The change in the vertical coordinates divided by the change in the horizontal coordinates. So the change in the vertical coordinates is going to be negative 2. I'm going to travel down 2 units from one point to another and travel right 3 units, right? Negative 2, 3 is going to let me travel in that direction. I could also technically put that negative on the 3. So again, we would say positive 2. I'm going to travel up 2 units instead. And then left 3, negative 1, 2, 3. And again, plot another point in that area. So again, I could follow that pattern. And you'll notice that no matter if I travel down and right or up and left, I'm getting that same row of points. I'm getting that pattern that's just going to travel. I missed them a little bit there, so I'm going to try taking another shot at that. Travel from point to point right along that line. Again, finish with a couple arrows, and we've got our graph. Now, that's not the only way to represent a graph. We also have, again, what's called point-slope form over here. It's a little bit longer equation. We could actually write that fairly simply from what we know. Let's take advantage of the fact that we know we traveled through the point 3, 2 here, right? If that's going to be the point 3, 2, then another equation for our line would have been to say y minus the y coordinate is equal to our slope, which is still a negative 2/3, times x minus our x coordinate. And again, that same equation would be plotted as that same blue line. It's the same slope. We just started in a different place. Instead of starting at 0, 4, we started at 3, 2, denoted by the x minus 3 and the y minus 2 in the formula. Now, there's a couple other formulas as well for linear equations. If we kind of played around and redistributed or maybe ran some numbers through our equations, we could also write them in standard form, ax plus by equals c, where a, b, and c are typically integer values, right? They're usually constants, positive and negative constants. Again, we still got our x and y for our variables. And if we kind of moved around, we kind of subtract that c over, there's also what's called general form. And basically, it just means that we're solved for 0. So again, a, b, and c are going to typically be integers. They wouldn't necessarily have to be, but typically integers. But again, we're solved for 0. We don't use general form quite as often. Usually in math, when things are general, they're not quite as useful. Again, they're widely used, but again, not as useful as knowing the slope, knowing the intercept, knowing a starting point. Let's take advantage of some of those ideas and let's see if we can't graph these equations here. So just thinking about some details. Over here at the left, we've got a standard form equation. Now, this is a great opportunity to use some x and y intercepts. If we really think about it, if I plugged in 0 for x, this 5x is going to disappear, right? That becomes 0. And then if I divide by negative 3 on both sides, I can figure out we're going to go through the point. Again, x was 0. Y will end up equal to negative 4. And we found ourselves a y-intercept, right? 0, negative 4. We could take advantage, do the same thing the other way around. Let's go ahead and erase a little bit here. What if we plugged in that 0 for the y coordinate, right? That means that negative 3 times 0 would turn to 0. We could divide by 5 on both sides. And here's where this method gets a little bit messy. Again, if y were 0, x would need to be 12 over 5, or basically 2.4 which may not be as easy to plot as we were hoping. That's why we probably want to go with a slightly better method. What if we just took our equation and we went ahead and solved for y? So let's take 5x and we're going to subtract it over to the other side. 3y will equal 12 minus 5x. Then let's divide both sides by -3. And we'll end up with y equals, again, 12 over -3 is -4. 5 over 3 would be a positive 5/3 x. And now we're in y equals mx plus b, or what would technically be b plus mx, right? There's your b, there's your slope. So basically we could start at -4, 0, -4, and use that slope of 5/3, up 5, right 3, up 5, 1, 2, 3, 4, 5, right 3, or down 5, left 3, and we could draw our line, right, directly through those points. Don't forget to label. I'm just going to call that 10 and 10, knowing I counted by ones, and we'd be in good shape. And notice that the point 2.40, right, would have been right on our line if I drew a nice straight line there. The two equations at the right are a little bit trickier, only because they seem trickier. Without a y value in that equation, x equals 3, what it's basically saying is y could be anything. The one thing I know is x needs to be 3. So if I travel to x is 3 and y is 0, that point would be on my graph. And x is 3, y is 10, or x is 3, y is -5. What you notice is you get a nice straight line here, a nice vertical line directly through your points. And that's what we know about the line x equals 3. Anytime we know it's just x equals, we know that that's a vertical line. In that same way, y equals -4. Well, what if we went down 4 units, y equals -4, but x could be 0, or 1, or 10, or -9. Well, in that case, again, if we connect those dots, we should get a very straight and very horizontal line. Right? Again, x could be anything, 0 or 1 or 10. The only thing we know is that y needed to be -4. So again, all of those points fall on that nice horizontal line. I hope that helps you in graphing lines. We'll have a few more reminders for you in another video. But again, if you have any questions, make sure you talk to your teacher, and have a great day.